Hello, my name is Jace Moore, and I will be giving a brief overview of the research I conducted over the summer of 2022. My summer research topic was over machine learning, but more specifically, using machine learning to detect distracted driving. I did this by using YOLOv5, which is a specific type of machine learning model, but I'll get more into that later on. First, I would like to discuss why this is an important topic. According to the National Highway Traffic Safety Administration, roughly 5% of fatal car accidents are caused by distracted driving. While this might seem like a lot, the number is actually decreased from 2010 by 2%. And while many things and factors have affected this number, it has been shown that the countermeasures that have been created, such as traffic violations for being distracted while driving, have led to this number decreasing. So let's get into what machine learning really is. So machine learning is a computer algorithm that is fed data, and then it learns from this data and is able to pick up patterns from the data that it is given. The specific form of machine learning that I used in this research is called object detection. And object detection is the data given to it is pictures, and it finds patterns inside of these pictures and then can pinpoint the patterns. The specific model I used, like I said in the title, is YOLOv5, and this stands for You Only Look Once version 5. The reason I chose this model is because it is faster and more accurate because of the way it actually makes these calculations to find the patterns. When machine learning models learn, it is called training. And since this YOLOv5 model is a pre-made model, it's fast and easy to use, and it is simple as just downloading it and then uploading your data into it. So I did that by collecting data from a dataset called TICaM, which consisted of images of a simulated environment of people performing tasks while driving. Some of these tasks included looking left, right, behind, using their phone, the radio, the glove box, and leaning forward. After I got these images, I used a website called RoboFlow to annotate them. And by annotate them, I mean draw a box over them, and that shows and label them, and that shows the machine learning model where to look for and what to look for. After I did that, I had a total of 9 classes, 8 of them being distractions and 1 of them being a normal driving class. After all of these images were annotated, the website RoboFlow compiled all of them and split them into 3 groups. So when a machine learning model trains or learns, it needs 3 groups of data. The first one being the train dataset. This is what the machine learning model uses to learn from. It then runs those predictions through a test group, and then it validates those tests with the validation group. All of these files were then uploaded into a Google Colab virtual environment, as using machine learning takes a lot of processing power, so it is just easier and faster to use virtual machines. Running this through Google Colab, though, while it is faster, it still took roughly 4 hours to fully train, but once it was, I then downloaded the custom model and uploaded it to a laptop that was then hooked up to a USB camera that was mounted into a car where real-time detection was used. So as you can see by the images here, it fully detected each one of the classes, starting with looking left, right, behind, using cell phone, using the radio, opening the glove box, leaning forward, hands off of the wheel, and driving normally. The graphs here are the accuracy of the boxes and what is inside of the boxes. And the graph on the right is the precision. The most important graph is this bottom left one, which stands for the mean average precision, or MAP, and that just is the overall precision of the entire model. So in conclusion, the results from this model had a MAP, or mean average precision, of 98%, which means the overall precision of this model was 98%. And from these results, it can be shown that the distracted driving model was successful in detecting the distracted drivers. However, there were some limitations. Using the data set that I used, the range in which I could have the camera and the angle of the camera was very dependent on the data set, and many of the images also had the same background, which also could interfere with detection. And I would like to thank Laxmi Sagwan Barkdal and the Southern Illinois Bridges to the Baccalaureate program at Southern Illinois University Carbondale for giving me this opportunity, and also Dr. Ning Yang for helping me with this project and letting me be their mentee. Thank you.